Welcome to Lesson 1.2, RAG versus Fine-Tuning, the Decision Framework. Learning Objectives. By the end of this lesson, you'll be able to explain what RAG is and how it works. Compare it head-to-head against fine-tuning. Make a confident decision about which approach fits a given problem, and design hybrid systems that combine the strengths of both. That last one is where things get genuinely interesting. What is RAG? RAG, Retrieval Augmented Generation, is the most common way to bring private or domain-specific knowledge into a language model. Chances are, even if you've never fine-tuned a model before, you've already built something RAG-like. It's the default first move for most teams, and for good reason. You don't touch the model at all. Here's the core idea. Instead of changing the model, you change what it reads before answering. The pipeline has 4 steps. First, you convert your documents, PDFs, websites, internal wikis, into embeddings and store them in a vector database. Second, when a user asks a question, you search that database for the most relevant chunks. Third, you prepend those chunks to the prompt as context. Fourth, the model reads that context and generates an answer grounded in your actual documents. The model itself never changes. You're just feeding it better information at inference time. This flowchart walks the full RAG pipeline from left to right. The user query enters the system and gets embedded, converted into a vector that captures its meaning. That vector is used to search the database and pull back the top K most relevant documents. Those documents get assembled into a structured prompt alongside the original question and any system instructions. The LLM then reads that augmented prompt and produces a response. The critical insight here is that the model never knows your documents. It just reads them fresh on every request, exactly like a human reading a brief before answering a question. RAG versus fine-tuning comparison. Here's how the two approaches stack up across the dimensions that actually matter in production. RAG doesn't touch the model weights. Fine-tuning does. That means RAG knowledge is trivially updatable. Swap out documents in the database and you're done. Fine-tuning requires a full retraining cycle whenever knowledge changes. RAG can incorporate real-time data. Fine-tuning is frozen at training time. On the flip side, fine-tuning wins decisively on specialized behavior, consistent personality, and output format. RAG gives you explainability. You can cite exactly which document drove an answer. Fine-tuning is more of a black box. And on latency, RAG adds a retrieval round trip. Fine-tuning is pure inference with nothing extra. This radar chart makes the trade-offs visual. Notice that fine-tuning scores higher on setup time, counterintuitively, because a well-maintained RAG pipeline with chunking, embedding, and retrieval tuning can take significant engineering effort. RAG edges ahead on inference speed when retrieval is fast and factual accuracy when the knowledge base is well curated. Custom style and tone is firmly in fine-tuning's territory. Data privacy scores are comparable. Both approaches can be run fully on-premise. The takeaway isn't that one approach is better. It's that they're optimized for different problems. When to use RAG? The clearest signal for RAG is when your knowledge changes faster than you can retrain a model. A news chatbot pulling in articles daily, a product documentation system updated every sprint, a legal research tool tracking new case law, a financial assistant consuming live market data. All of these are RAG territory. The knowledge base is the moving part, and RAG lets you update it without ever touching the model. That's a massive operational advantage. RAG is also the right call whenever your users need to trust and verify the answer. Medical advice that must reference specific studies, legal guidance that must cite statutes, customer support that links back to knowledge base articles. In all of these cases, the ability to say, here's exactly where this answer came from, isn't a nice to have. It's a requirement. Fine-tuning can't give you that. Scale is another factor. If your knowledge base runs to thousands of documents, enterprise documentation, a Wikipedia-style corpus, a live customer database, you can't fit that into a context window or a training data set. RAG was built for exactly this. Retrieve only what's relevant when it's relevant at query time. Finally, data privacy can force your hand toward RAG. If sensitive documents can't leave your infrastructure, patient records, proprietary financials, classified internal data, you can run a local vector database and a local model without any data ever leaving your servers. You also get an audit trail. You know exactly which documents were retrieved for any given response. That matters enormously in regulated industries. Here's a concrete example of RAG in action. A user asks how to reset their password. The system searches a knowledge base of over 1,000 support articles updated daily and retrieves the password reset guide. That document's text gets injected into the prompt, the LLM reads it and generates a precise answer, and the response includes a citation pointing to the specific guide version used. No retraining required when the guide changes tomorrow. Just update the document in the database and every future query automatically picks up the new version. When to use fine-tuning? Fine-tuning earns its place when the base model simply can't do what you need, not because it lacks information, but because it lacks a skill or reasoning pattern. Medical image analysis requires diagnostic reasoning the base model was never trained to apply. Legal work in a specific jurisdiction requires argument structures that don't emerge from prompting. Generating code that conforms to your company's internal standards requires knowing those standards deeply. If you've tried prompt engineering and you're stuck at 80% quality with no clear path forward, that's the signal to fine-tune. Personality and voice are where fine-tuning has no real competition. You can prompt a model to be friendly or sound like Hemingway, and you'll get something in the ballpark, maybe 70 or 80% there. But to genuinely capture a specific voice, a specific rhythm, a particular brand of humor or bluntness, you need demonstrations. You need to show the model hundreds or thousands of examples of exactly the tone you want. That's fine-tuning. Prompting alone can't get you the last 20%, and in consumer-facing products, that last 20% is everything. Structured output reliability is another strong case for fine-tuning. If your application requires the model to always return valid JSON, not usually, not mostly, but always, fine-tuning on examples of correct output gets you to 99+% reliability. The same applies to SQL generation, API call formatting, or any domain where malformed output causes downstream failures. Prompting can improve reliability, but fine-tuning locks it in. Cost at scale is worth taking seriously. If you're running thousands of requests per day against GPT-4, those per token costs add up fast. A fine-tuned Llama 3.8b running on your own hardware can match GPT-4's quality on your specific task at a fraction of the cost per query. The upfront training investment pays off quickly at volume, and on-premise deployment eliminates per-token charges entirely. There's one more case that surprises people. Tasks where the desired behavior is genuinely hard to describe in words. Try writing a prompt that produces beautiful ASCII art. What does beautiful mean in that context? You can't define it, you can only show examples. Same with humor. Telling a model be funny produces something earnest and slightly painful. Showing it 1,000 examples of genuinely funny outputs, that works. When the behavior you want lives in the demonstrations rather than the instructions, fine-tuning is the only path. Here's a medical example that illustrates why fine-tuning is sometimes non-negotiable. The task is analyzing patient symptoms and generating structured diagnoses in JSON format, output that feeds directly into electronic medical records. The training data is 10,000 anonymized patient cases, each containing symptoms, diagnosis, and confidence level, plus hospital-specific protocols. RAG could surface relevant medical literature, but it can't teach the model the diagnostic reasoning process itself, or guarantee that every output matches the required JSON schema. Fine-tuning does both. The model learns the reasoning pattern from the examples, and the output format gets baked in through repetition. The hybrid approach, best of both worlds. The most powerful systems don't choose between RAG and fine-tuning. They use both. RAG handles the parts of the problem that change, the knowledge base, the real-time data, the document corpus. Fine-tuning handles the parts that stay constant, how the model reasons, how it speaks, what it refuses to do, and what format it outputs. Combined, you get a system that stays current without retraining and behaves consistently without relying on fragile prompt engineering. Think of it as a division of labor. RAG owns dynamic knowledge, anything that updates frequently, anything that needs citations, anything too large to train on. Fine-tuning owns behavior, domain-specific reasoning, consistent tone and personality, structured output, and specialized task performance. Neither approach has to carry the full weight of the problem. Each does what it's best at. Here's what the fine-tuning side of a hybrid system looks like in practice. You're training Llama 3.8b on your company's specific tone and voice, your product terminology, your escalation protocols, when to hand off to a human agent, and your refusal policies. The model doesn't need to memorize product specs or policy documents. RAG will supply those at query time. What the model needs to internalize is how your company communicates and reasons. That's exactly what fine-tuning delivers. And here's the full hybrid pipeline end to end. A user query comes in. The RAG system retrieves relevant product manuals and FAQs from the vector database. Those documents get passed to the fine-tuned model, which has been trained to understand company jargon, adopt the brand's voice, and recognize escalation triggers. The model reads the retrieved context through the lens of its fine-tuned knowledge and generates a response that is both factually grounded and on brand, with citations from the retrieved documents included. Neither component could produce this result alone. Decision framework. This decision tree gives you a repeatable process for any new project. Start with one question. How often does the information change? If it's daily or weekly, RAG is your default. If the knowledge is more stable, ask whether it's primarily factual or behavioral. Factual and stable, RAG still works well unless the domain is highly specialized. Behavioral, specific style, reasoning, output format, that's fine-tuning territory. Need both dynamic knowledge and consistent behavior? That's your hybrid signal. Run through this tree for any new use case and you land in the right place the vast majority of the time. Worked examples. Scenario 1. A customer service chatbot for a news platform. Knowledge changes daily, new articles constantly. Behavior is standard question and answer. The decision is fine-tuning would be outdated within days of training, and the base model's Q&A capability is already sufficient. No fine-tuning needed. Scenario 2. A writing assistant that mimics Paul Graham's essay style. His essays are a fixed corpus. They don't change. The challenge is entirely behavioral, capturing a specific voice, rhythm, and way of structuring arguments. The decision is fine-tuning. This is exactly the case where demonstrations outperform instructions. You can't prompt your way to a convincing stylistic match. Scenario 3. An internal documentation search tool. Some documents update regularly, some are static, and users need to cite sources. The behavior required is standard search and retrieval, nothing the base model can't handle. The decision is RAG, The primary need is access to a changing document corpus with traceable citations, and RAG delivers both. Scenario 4. A legal contract analysis assistant. Laws and case law do change, not daily, but regularly enough that a fine-tuned model would drift out of date. The reasoning required is highly specialized: jurisdiction-specific logic, contract structure analysis, clause interpretation. The decision is hybrid. RAG keeps the model current on the latest case law, and fine-tuning instills the specialized legal reasoning that no amount of prompting reliably produces. Scenario 5. An API integration layer that converts natural language requests into JSON API calls. The API schema is stable. The non-negotiable requirement is that every single output is valid JSON, no exceptions, because malformed output breaks the downstream system. The decision is fine-tuning. Training on examples of correct JSON output pushes reliability above 99%. Prompting alone won't get you there consistently. Key insights. 5 things worth internalizing from this lesson. RAG is the right starting point for most knowledge tasks. Lower complexity, faster iteration. Fine-tuning is the right tool when behavior is the problem, not information. Hybrid systems are genuinely powerful and worth designing for from the start on complex applications. Time horizon is a decisive factor. If knowledge changes daily, RAG. If it's stable, fine-tuning becomes viable. And quality of inputs determines quality of outputs in both approaches. RAG depends on retrieval precision. Fine-tuning depends on training data quality. Neither approach rescues you from bad inputs. Exercise. Classify these use cases. Work through these 5 scenarios and decide: RAG, fine-tuning, or hybrid. And more importantly, articulate why. First, a restaurant recommendation chatbot that needs current hours, menus, and reviews, but should have a friendly local person. Second, a natural language to SQL converter where the database schema is fixed. Third, an academic paper Q&A tool where new papers get uploaded regularly and citations matter. Fourth, a medical coding assistant that maps diagnoses to ICD-10 codes which update annually, requiring deep understanding of medical terminology. Fifth, a generator that writes sonnets in Shakespeare style, trained on a fixed historical corpus. For each one, trace through the decision framework, frequency of change, factual versus behavioral, and whether you need both. The answers are in the lesson materials, but reason through them yourself first. That reasoning process is the skill you're building. Assignment. Plan your project. Take the project idea you identified in lesson 1.1 and run it through this framework. Answer 5 questions. What knowledge or capability are you adding? How frequently does that knowledge change? Is the primary challenge factual, getting the right information, or behavioral, getting the right style, reasoning, or output format? Based on those answers, which approach does the framework point to? RAG, fine-tuning, or hybrid? And finally, why? What's the specific characteristic of your use case that drives that decision? Here's an example answer to show what this looks like in practice. The project is an HR policy chatbot. Policies update quarterly, so a purely fine-tuned model would go stale. But the tone needs to be consistently professional, something RAG alone can't guarantee. The decision is hybrid. RAG retrieves current policy documents at query time, ensuring factual accuracy even after updates. Fine-tuning establishes the professional tone and communication style that should remain constant regardless of which policy document gets retrieved. The quarterly update cycle is frequent enough to make pure fine-tuning impractical, but infrequent enough that maintaining the RAG database is manageable. Hold on to your answers. They'll form the foundation of your Module 7 capstone project. Key takeaways. The single most important distinction in this entire lesson, RAG is for knowledge, fine-tuning is for behavior. RAG gives you dynamic, updatable, citable information. Fine-tuning gives you consistent personality, specialized reasoning, and reliable output formats. Hybrid systems give you both, and for production applications that need to be both current and capable, hybrid is often the right architecture from day one. When in doubt, start simple. Build the RAG system first. Measure where it falls short, and add fine-tuning precisely where behavior is the gap. Next lesson, you now have a principal framework for deciding between RAG, fine-tuning, and hybrid approaches. Next up is lesson 1.3, how large language models are trained, where you'll build a mental model of what actually happens inside a model during fine-tuning. That understanding will make every decision in this course sharper. And if you're still uncertain about your own use case, that's completely normal. The next few lessons will give you enough depth that your decision will crystallize on its own. Skip forwards. Skip, 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 for, skip, for, ho, 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 skip